Hi everyone, now we are going to discuss about the connections of capacitor in different circuit. We can connect capacitor in two different methods, capacitors in series and capacitors in parallel. First we are going to discuss about capacitors in series. So for that we are considering a series connection of capacitors. Capacitance of first capacitor is C1 and capacitance of second capacitor is C2, and for this capacitor the capacitance is C3. Here the charge is same. The charge is same everywhere. In every capacitor the charge is same. The potential of this capacitor is V1 and this capacitor is V2 and this capacitor is V3. Then how we can find the total potential? We need to add V1 plus V2 plus V3. Here the charge is same and the expression for V1 is Q by C1. Expression for V2 is Q by C2 and expression for V3 is Q by C3. And total potential V equal to V1 plus V2 plus V3. Now we need to find the value of V. So for that we are considering a single capacitor. We are going to place this capacitor instead of these three capacitors. So when we are placing this capacitor, we will get equivalent capacitance of this capacitor. So now what is the value of V? Here charge is Q and C is the capacitance, so V will be equal to Q by C. We are substituting all the values in this equation. It will be Q by C equal to Q by C1 plus Q by C2 plus Q by C3. Q will cancel each other and it will be 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now capacitors in parallel. So we are considering a parallel connection. These capacitors are in parallel and this voltage is V, this is Q1, the capacitance is C1, Q2, C2, Q3, C3. And here the voltage, the potential is same everywhere. In each capacitor is having same potential. Potential is same. How we can find the total charge? Q1 plus Q2 plus Q3. What is Q1? The equation of Q is CV. Here Q1 is C1V, Q2 is C2V and Q3 is C3V. Now we are considering a single capacitor. We are going to place this single capacitor instead of these three capacitors. So we can find equivalent capacitance. The charge Q is C into V. So we can write Q is equal to C into V. So we got for equation for Q1, Q2, Q3, Q. This value we can substitute here. So it will be CV equal to C1V plus C2V plus C3V. We need to find the value of C and V is common. So it will cancel and C equal to C1 plus C2 plus C3. So in parallel connection, the effective capacitance is C equal to C1 plus C2 plus C3. If the capacitors are in series, the equation is 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. If the capacitors are in parallel, C equal to C1 plus C2 plus C3.